So therefore, welcome back. This is our second lesson. Last week, we learned what research is. We defined research according to various scholars. We classified research according to discipline, according to practice, and according to data collection method. And also, we looked at the importance of research. Now, today, we are going to look at the concepts that are used in research. And one of the concepts that are used in research is what we call problem statement. Let me start by saying, start with this particular term known as problem statement. And this is a precise formulation of the problem to be investigated. Before you start a research, remember last time we said that when you do a research, the research that you're conducting must be of importance. If you're conducting a research and its result is not going to be of importance to anyone, then there is no need of conducting that research. And therefore, when you come up with a problem is what you're going to investigate. That problem you need to formulate it. To formulate simply means you have to put it down in a way that it can be understood. So problem statement is formulation of the problem to be investigated. It is actually a definition of what the investigator proposes to do. For example, if you want to find out the effect of TV on young children, that is the problem. Now put it down in a way that it can be understood. So the statement should therefore bring into being a distinct image of the problem that needs to be investigated. People need to know exactly what you're going to investigate or the kind of problem you're going to investigate. Therefore, it should be clearly indicate to the reader what the researcher has in mind. For example, when you're putting it down that effect of TV on young children, you need to give us or to tell us clearly what you have in mind. So the statement of research problem, which logically follows from the background, could range from one or more paragraphs. So it can be 2 paragraphs, 1 paragraph, you trying to explain to us what the problem is all about. So it ends in 3 forms, either definite statement, a question, or a hypothesis. The next one is what we call a variable. A variable is anything that has got what we call changing quantities. Changing quantities are referred to as variable. And a variable therefore can be defined as any entity that can take in different values. For example, age is a variable. Sex is a variable. Occupation is a variable. Height is a variable. Variable is anything that can take different entities. That means that anything that can vary can be considered as a variable. For instance, age, we have just given an example of age, can be considered as a variable because people have got different ages. There are people who are 3 years old. There is one who is 0 years old. There is somebody who has just been born today is 0 years old, or some few hours or few minutes old. And then we also have what we call, there are people who are 80 years old, 120 years old, and so on and so forth. So it is a value that is taking various entities. Similarly, a country can be considered as a variable because a person's country can be assigned a value. Like you can assign Kenya value 1, Tanzania value 2, maybe Uganda value 3, and so on and so forth. So anything that can vary is considered a variable. What is the opposite of a variable? The opposite of a variable is what we call a constant. Is it a constant? Yes, it is a constant. So that is it. So Dominic defines a variable as a phenomenon or event that can be measured or manipulated, and it is used in the development of constants. Another scholar called Kallinger, 1973, states that a variable is a property that takes on different values. We have said that. Putting it pointedly, he states that a variable is something that varies. So there are those things that cannot vary. Those things that cannot vary, we call them constants. Other variables are polytomies. A good example is religious preference. For example, Protestant, Catholic, Muslim, African, traditional religion, etc. So research attempts to test number of associated variables to develop an underlying meaning or relationship among them. So it is very important to note that variables are not always quantitative or numerical. Last week we said that quantitative is something that can take numerical values. So variables are not only those things that can take numerical values. For instance, the variable gender consists of two text values. You are either a male or a female. We can, if it is useful, to assign quantities values instead of or in place of the text values, but we don't have to assign numbers in order for something to be a variable. You don't have to assign something a number for it to be a variable. Another term to note while talking about variables is attribute. An attribute is a specific value of a variable. It's a specific value of a variable. For instance, the variable sex or gender has two attributes. If you're talking about a gender or sex, it is either male or female. Leave about the other genders. Those ones we don't recognize them. So for instance, the variable sex or gender has two attributes, male or female. So whenever you're talking about an attribute is a specific value of a variable. So variables can have a value. So those value is what we call attributes. And we've given a very good example, like whenever you're talking about sex or whenever you're talking about gender, this gender or sex can have two attributes, either male or female. Then from there, we look at, we have this one, we are going to look at it later. We have dependent and independent variables. Variables are classified in terms of their relationship with one another. The relationship between variables is how that helps us classify them. So researcher usually talks about what we call independent variables or dependent variables. And the most important and useful way to categorize variable is as independent and dependent variables. Even though we also have other variables, like we have not the consequent, we have extraneous variable, we have extraneous variable among others. So variables, the most important, the one that you should actually know from the word go is what we call independent and dependent variables. And therefore, according to Kallinger 1973, the most important and useful way to categorize variable is as independent and dependent. So we go to the next thing. This guy called Kallinger 1973 defines an independent variable as presumed cause of the dependent variable. As presumed cause, it is the one that is causing the dependent variable. So Kallinger says that independent variable is the presumed cause of the dependent variable. So without the independent variable, the dependent variable cannot be there. Then the presumed effect, the dependent variable is the presumed effect. Like, for example, when you talk about effect of TV on young children, who can tell us what is the dependent variable and which one is the independent variable? Do we have someone who can tell us which is the independent variable and the dependent variable? We can say the effect of TV on young children. Yeah, the effect of TV on young children. So the independent variable is also known as the antecedent, while the dependent variable is usually known as the consequent. Remember, we have said that independent variable is the presumed cause, and the dependent variable is the presumed effect, the consequent. So the presumed effect, that is the dependent variable, is also known as the consequent, while the independent variable is known as the antecedent. When we say if A, then B, we have a conditional conjunction of an independent variable. So we can, in other words, the dependent variable is what the researcher wishes to explain. We are going to look at an example later. The dependent variables are the things we measure about people. For example, you are being told, assume that a researcher is interested in determining how the newscaster's mode of dressing affect an audience perception. So assume you are the researcher and you are interested in knowing how the newscasters or how the reporter's mode of dressing affect an audience perception of the credibility of television station. Because some people will look at the way you dress and will tell that news is not credible because of the mode of dressing. Now, assume that the researcher is interested in determining how the newscaster's mode of dressing affect an audience perception of the credibility of a TV station. So two different modes of dressing, that is the native or the English dressing, are selected for investigation. So that is, we are saying that one newscaster is told dress in native dressing, and the other one is told dress in English dressing. So respondents are randomly assigned to view, they are assigned to view two newscasters, one in African attire and the other one in a suit. And then they are asked to complete questionnaires that measures credibility. So in this experiment, the mode of dressing is the independent variable. The mode of dressing is the independent variable because its values are systematically varied by the researcher because it is through the dressing that you will tell whether it is credible or not credible. So that's why we are saying the mode of dressing is the independent variable. The dependent variable to be measured is the perceived credibility, because perceived credibility can change. It can be neutral, it can be negative, it can be positive, it can be something else. So the dependent variable here is the perceived credibility of television station. I don't want to go into so much. Then there are other types of variables. You're going to read them: control variable, organismic variable, constant variables, etc. Then we also have what we call research questions or hypotheses. A research question, these are questions that you develop. These are questions that you develop when you're conducting your research that you think your research will be able to answer. So then we are talking about research questions, and we are saying research questions are questions that you develop depending on the research topic that you have. Of course, we also have what we call research objectives. After research objectives, you then come up with what we call, you can develop what we call research questions. Research questions are questions that you develop that at the end of you conducting that research, the research must be able to answer those questions that you have developed there. So those are called research questions. On the other hand, when you talk about hypotheses, these are assumptions. Hypotheses are assumptions. The assumptions that you think leads to something. Like, for example, you might say that students did not or do not come attend online classes because they have problem with buying bundles. That is an assumption. You can also say that students do not join online classes because maybe they are not comfortable with it, or other reasons. Now, when you conduct your research, you will be proving your hypothesis. The research that you're conducting proves your assumptions as either true or false. So when you go to the field now, you start conducting research on why students don't join class or online classes, then you will be able to do what? The research will be able now to answer your assumptions. So when you talk about research questions, these are questions that you develop before you do a research. Then after conducting the research will be able to answer those questions that you have developed. On the other hand, when you talk about hypotheses, these are simply assumptions. Sometimes we call them educated guess. It's an educated guess that when you come up with those educated guesses, after conducting your research will either prove your educated guesses as either true or false. I think I've explained hypotheses. Now, you read on differences between research questions and hypotheses, and then advantages of hypotheses. We can look at them. They provide direction for a study, because you can imagine you having a research problem, or you have a research topic that you're investigating and you don't have a hypothesis. Hypotheses or assumptions or educated guesses, they provide direction for your study. They help you to know, what am I looking for? Number two, they eliminate what we call trial and error research. That I am not just doing a research for the sake of it. I am doing a research so that this research can answer or can prove my hypothesis as either true or false. Number three, we are saying that hypotheses help rule out intervening and confounding variables. Intervening variables are those variables that interferes with your research. They interfere with your research. You cannot do away with them, but you can minimize the effect of intervening variables. For example, in communication, we usually have noise. Noise is a variable. We usually have noise. You can minimize the effect of noise, but you cannot do away with noise completely. For example, in communication, we have psychological noise, we have physical noise, we have semantic noise, among many others. So you might say, I'm going to sit in a place whereby I will not hear any physical noise. Of course, you have minimized the effect of noise. You say, I'm going to use the best, I'm going to be very articulate with words, and I'm going to avoid semantic noise. Yani, those noise that comes from the way we pronounce things and how we say things. And then now you are ready to learn. As you are ready to learn, there are other noises that comes in, like psychological noise. That's why we are saying noise is an intervening variable, because you can minimize its effect, but you cannot do away with noise completely. The next point is hypotheses allow for quantification of variables. That is, they make operationalization of concepts easier, and words incapable of quantification are excluded. Then we've also talked about research questions. And then the last one is what we call research objectives. Any research has got what we call objectives. And first of all, when you're conducting your research, we usually have what we call a general objective. Then from the general objective, you come up with specific objectives. So, so there are two types of objectives, or there are two types of objective: a general objective or ultimate. And then secondly, we also have what we call, so the general objective states what is expected to happen. And then we have specific or immediate objective. Specific objectives, they are very specific. They are very specific. Any question up to that point? Any question? Remember, today we are looking at concepts. So it is important for you as a researcher to acquire a sound understanding of the basic terms that are used in research. And this acquisition of language is important for the better understanding of the research process, as will be outlined in the subsequent chapters or topics. Now, the reason as to why today we are learning the concepts, because this concept, you will hear them. From today's lesson henceforth, I'm going to be using concepts. And if you don't understand this concept, then it is going to be very difficult. This unit is going to be very difficult for you. So you better understand these concepts and understand them very well, because it is through understanding the concepts that makes even my work easier and also your work easier. So that's why we are looking at the concepts of research. We need to understand them. And once we understand these concepts, then understanding, because from today's class henceforth, I'll be using those concepts. I will not be telling you a variable and then I take you back. I tell you a variable is something that takes a different value. I will not be talking about that. I will just be saying, like, these two variables. I'll be saying, give me an example of variable. You must be in a position to understand these concepts. There is no way out, by the way. There is no way out. You really must know these concepts, because these concepts or these terms are the ones that we are going to use from today henceforth. And even when you will be progressing with your education, they will be using these concepts. Number one is what we call population. There are so many concepts here. There are approximately 33 concepts that you need to understand. So we also have we have population, and population is the entire group of individuals. For example, if you go to University of Nairobi, the students, everybody who has registered there for PhD, for master's degree and or postgraduate and undergraduate programs, or everybody there is a student. Now, if you go there, everybody who has registered there for a course is a student, and therefore we can call it the population. The population. So population is the entire group of the individual. Like, for example, you can talk about our country, Kenya. We have a population of maybe approximately 48 million Kenyans. That is the population. It is the entire group events that have a common observable characteristic. Like, for example, in Kenya, all of us are Kenyans, and all of us are depending on, all of us are working in this particular Kenya, and we all pay taxes. We all do this. We all use government facilities, and so on and so forth. So population is the entire group of individual events that have common observable characteristics, and it's connoted as capital N. Sometimes you'll find when you're doing a research, capital N simply means that is a population. Then the next one, I've given an example. It is explained there. We also have a sample. A sample is a subset of the population. It's a small portion that you take from the population. It's carefully selected subgroup of accessible population that is representative of the whole population. Like, for example, we might have a class, this class of mine, the research methods class. I might have 50 students in this class. Now, 50 students, as far as that class is concerned, that is the population of that particular class. I may decide to pick 5 students from the 50 students. that will represent the what? The total population. Now, the sample that I get, what I pick, like 5 students from the total population of 50, that is what we call a sample. A very good example is when we had COVID-19. There were so many tests that were being done. You'll hear the then CS Minister for Health, Mr. Mutahi Kagwe, would say out of 5,000 people tested, maybe 2,500 tested positive. So because the 5,000 is a sample. Remember, in Kenya we are more than 45 million Kenyans. So the 5,000 is simply a sample from a specific area. So out of 5,000 samples tested, 1,000, maybe 200 tested positive. So sample is a subset or a subgroup of the population that has got the same characteristics. That's why they would use the sample to tell you that that out of 10 Kenyans, 2 people have COVID-19 or are COVID-19 positive. So then sampling is the process of you selecting getting the sample from the population. That is what we call sampling. The process of selecting number of individuals for the study. That process that you are using, collect a sample from a population, is called sampling. Then sampling frame is simply a list, a directory or index of cases from which a sample is selected. For example, we might decide to have a sampling frame of income taxpayers only. So we are looking at income taxpayers, wale watu wanalipanga tax Kenya hii. That is a sampling frame. Or we might be looking at students doing diplomas at maybe, for example, University of Nairobi. That is the sampling frame. Then there is what we call probability sampling. Probability sampling is a sampling technique that is conducted. It's a way of collecting samples from a population. It's a method that is used of collecting samples from a population. And probability sampling technique, it simply states that every individual or every variable or every item in the population has an equal chance of being selected because it is probability. The non-probability sampling, it simply means that all the individuals do not have an equal chance of being selected in a population. For instance, it will be difficult to have a list of all the mentally challenged in the society because probably not even our hospitals have the comprehensive list. It's very, very, very difficult. Then we also have parameters. Parameter is a measurable characteristic that can assume different values. So do not confuse parameters with variables, because we have said that a variable is a variable. Let's go to a variable. A variable is a measurable characteristic that can assume different values. I want you to get this right. A variable is a measurable characteristic that can assume different values. Measurable characteristic that can assume different values. A parameter is a measurable characteristic that can assume different values. What is the difference? So the difference between parameter and variable is that while the variable is related to characteristic, a sample drawn from the population, parameter refers to population characteristics. In other words, we are saying parameter refers to characteristics of a sample. Parameter refers to characteristics of a sample, while population refers to characteristics of a population. That is the difference between the two. Parameter refers to characteristics of a sample, while variable refers to characteristics of a population. Then we also have statistics. It's a science of organizing, describing, and analyzing quantitative data. Then from there, we also have independent variables. This one, we have looked at them. We have looked at dependent variable and independent variable, where we are talking about antecedent and consequent, and so on and so forth. Then we also have control variables. Control variables are the variables that the researcher suspects is likely to influence the research results. So there are different types of variables that may influence results of the study without the researcher being aware of them. Those are called control variables. Extraneous variable, they are variables which influence the results of the study when they are not controlled. Like we talked about noise, and we said you need to control the noise. You cannot do away with it completely, but you can minimize its effect. Then we also have intervening variables. These are special types of an extraneous variable, and the only difference is that with an extraneous variable, there may be no causal link between the independent and the dependent variable. Then we have a theory. A theory is a tentative explanation of the world around you. So a theory explains why things are the way they are around you. So theories have been formulated by various scholars, various philosophers, and various academicians to explain why things they are the way they or why things happen the way they do. Like, for example, you might ask yourself, why do employees strike when they do not receive pay rise? You'll find Akina McGregory with theory X and Y. You'll find people like Maslow's with hierarchy of needs. You'll find people with, there are so many scholars who have spoken about theories of motivation. There are also theories of communication, theories of mass media, and so on and so forth. So these theories, they explain why things happen the way they do. A hypothesis, we have talked about it. We have said that it is an educated guess or it is an assumption. Then from that assumption, we have null hypothesis. And this is the default state of nature. A null hypothesis assumes that there is no relationship or differences between variables. You see, already we have started using terms. We have started using terms like a variable. So if you're in this class and you did not get what a variable is, you will be forced to go back and read what a variable is. So it is the default state of nature. It assumes that there is no relationship between the dependent and the independent variable. Then we also have alternate hypothesis. It's a research hypothesis which represents the researcher's anticipated explanation. Then we also have type 1 error. Go and read about type 1 error, or maybe you can go through them. Type 1 error is known as false positive error. False positive error or false alarm. A very good example is sometimes you can go to hospital and you are misdiagnosed for malaria. While the test that you are being done, it proves otherwise. That is called type 1 error, that you go to a hospital and you are misdiagnosed for malaria. While the tests that are done on you, they prove otherwise, that you don't have malaria. But you are being misdiagnosed for malaria. Type 2 error, a very good example, it's also known as false negative error. So it occurs when the relationship does not exist, but your analysis fails to show. It occurs when a relationship does exist, when a relationship is existing, but when you do your analysis, it shows that there is no, it fails to show anything. It usually occurs because of small sample size. Like when you pick a small sample, look, now we are using what we call the terms ambazo tunasoma sahi. We have now started using them. The small sample size. We have said that a sample is a subgroup of a population. So when you pick a subgroup of a population that is not large enough, then you're going to have type 2 error. You're going to have, you're going to be conducting a research, and then it is going to give you a false negative error. So we have said that it occurs when a relationship does exist, but your analysis fails to show. And this is as a result of you picking a small sample size. Then there is what we call type 1 and type 2. They are associated with hypothesis testing. Remember, we have talked about hypothesis testing, and we have said that it is an educated guess. It is an assumption. These hypotheses that you're coming up in your research, they have to be tested by your research. Once you conduct your research, then your research will prove your hypothesis to be true or false. So there are what we call type 1 and type 2 errors, and there are 2 other types of errors that are associated with sampling, and they are referred to as sampling error and sampling bias. So a sampling error, we have said that a sampling error is an error that is inherent in every sample, because it is almost impossible to have a sample that is replica of the population. So this kind of error is non-systematic, because it could be a case of outlier being included in the sample. Then sampling bias is, it comes, the researcher may have included or excluded some important cases in the study. So once you include or you exclude some cases in the study, then you're going to get a sampling bias. A normal curve, you're going to read about a normal curve. Data, we know it refers to all the information that a researcher gathers for his or her study. Descriptive statistics, you're going to read about it. Then we can look at unit of analysis, or maybe we can look at non-parametric tests. They're also called distribution-free tests of hypothesis. They're usually used when the population is not normally distributed. When the population is normally distributed, it leads to what we call a normal curve. A normal curve, we have seen a normal curve there. Then the unit of analysis is also called the unit of statistical analysis. It refers to those units that we initially described for the purpose of aggregating their characteristics in order to describe some larger group or abstract phenomena. Unit of analysis is therefore the individual units about which or whom descriptive or explanatory statements are made. Unit of observation is the subject, object, item, or entity from which we measure the characteristic or obtain data required in research study. For example, you are being told a house, a pupil in class, etc. We refer to what we call a unit of observation. Any question up to that point? Any question up to that point? If there is no question, it means 2 things. Either you have understood, or either you have not understood anything. I will take it positive. Take it positive. I believe you have understood everything I have taught. So there are activities there that I want you to do. Activity 1 is a discussion forum, and you are being told to discuss at least 10 basic importance of hypotheses and give examples. The next thing is the quiz 2. Explain how various terms relate or build each other. Like, for example, when you talk about type 1 error and type 2. Type 1 error and type 2, they build each other to come up with type 1 and type 2 errors. So explain how various terms relate or build each other. Like, for example, when you talk about a population and a sample, how do they build each other? You cannot talk about a sample without talking about a population. So then there is quiz 2 there. It is waiting for you. So, and that marks the end of today's lesson. unless there is a question.